Hey guys, that last question was fun, so let's do another one. This one's going to come from the 2016 midterm, and we are given a Ramsey economy with a normal utility function with a slightly abnormal utility of consumption function, so we'll keep that in mind. We have an explicit Cobb-Douglas function for our production function, so instead of all of those f's and f primes, we're actually going to have the exact value of k hat. That'll be nice for doing the phase diagram comparisons. And there's a sales tax on the firm's output. So we'll have to use that in part B, I think. So let's start with part A, and I've even made a handy dandy to-do chart for us. So I think this video we can do the first three, 1, 2, 3, and then in the next one we'll actually solve the Hamiltonian and get the Euler equation. I think I said Euler in the last video, so that's really embarrassing. Somebody please kill me. Intertemporal budget constraint. We want to know what is little a dot. And we know what is big A dot. That's just equal to the wage times the population plus the accumulated capital. Whoops, that's going to be A. Accumulated capital of the households times its rental value minus big C consumption. And we're going to divide everything by n. Same exact process. I think this is easy. It's just kind of like steps to memorize. Because if you don't, I imagine you won't get full marks if you just write down the answer directly, because it's pretty much the same every time. But it's good to know how to derive it. So now we got to shake the bag, make that a dot n fall out. So here we get a dot n minus n dot a over n n and n n. And this is going to be little a dot is equal to a dot over n minus na. Remember that n dot over n is a growth rate equal to n, and we defined a dot over n as little a. And we know the value of this is just this guy over here. So let's plug him in. A dot is equal to W plus AR minus C minus NA. Reorganizing, we get the intertemporal budget constraint, which will just be the same as always. Wage plus assets times rent minus population growth minus consumption. And that is the rate of savings, as it were. All right, let's do the Hamiltonian, because that's easy. The Hamiltonian is always just the utility function without this integral part, and then the budget constraint here, plus our little mu guy. So let's switch colors. We're going to have Hamiltonian for consumption, assets, time, and nu is equal to, I'm going to split this fraction actually to make it a little bit easier to see, because if we take that CT 1 minus theta minus 1 over 1 minus theta, that's the same thing as CT 1 minus theta over 1 minus theta minus 1 over 1 minus theta, right? So, and that's all going to be multiplied by e to the minus rho minus nt, but I think for taking the derivatives this will be a little bit easier. I'll even factor through, I'll even like FOIL through the e. So we'll take ct to the 1 minus theta over 1 minus theta e to the minus rho minus nt minus 1 over 1 minus theta e to the minus rho minus nt plus nu times the budget constraint, W plus A, R minus N, minus C. And the first order conditions are always the same. We need one for consumption, that will equal 0. And we need one for assets, and that will equal minus nu dot. And the transversality condition, as always, is that as time goes on forever, we will not leave anything behind after our dynasty is dead. And there you have it. That's task 1, check. Task 2 check, and task 3 check. And next time we're going to solve this Hamiltonian with these first order conditions and find the Euler equation. See you then.